Hello, everybody, and welcome to our talk on contract testing, or how do you tame an external API that constantly breaks your tests. So this talk is a case study. It's a personal story about how we went about solving a problem we had. So let me introduce you to the characters of the story. So this right here is a schematic diagram of our development setup. And what you see on the top right, there is the creatively named dev system. That's where we do our development. And on the left-hand side is the villain of the story, the external API that constantly breaks our tests. So this external API is an agent of entropy, and it is as annotated by this lightning mark here. And this is developed by a backend team which is external to our team. We are a predominantly front-end focused team, and therefore we had extensive coverage against our front end in the form of these front-end tests. And we had assumed that our implementation partners who own the backend are going to be testing the backend on our behalf. Now, when you make an assumption like that, you already know what is coming. In October 2021, we were struck by lightning. What happened was our external team that was maintaining the API made a major change to their backend, and this broke all our tests. We saw that the response status was not what we expected. The data didn't come in the right format, or what was missing key data. And it took us 172 hours. We counted. That's more than 21 painstaking days in the life of a developer for us to fix this and get back on track. And during this entire duration, our pipeline was red. But hey, the show must go on. So we continued building new features. And this right there perfectly summed up the mood in the team when we are doing this. So ever since we've come a long way, we've seen the amount of time it takes for us to recover from these upgrades reduced drastically. As recently as March 2023, it took us merely 4 hours to recover from an overhaul of the backend API. The motivation for this talk was to tell you about how we got from here to here. I'm Anupam Krishnamurthy. I work as an SDET or a test automation engineer. And we work for this really cool firm called BitGrip. We work out of the center of Berlin. We're about 70 people strong. You can check us out at bitgrip.com. So first up, I'd like to have a show of hands. How many of you present here develop an application that depends on an external API? Okay, keep those hands in the air. Keep those hands in the air. How many of you work closely with the external team that builds this API? Continue keeping these hands raised. How many of you are frustrated with this setup? Oh, I didn't see one hand go down. So, dear folks, this talk is dedicated to you. We feel your pain. Building software essentially means working with external teams closely and often end up being frustrated with the setup. So think of this talk as relationship advice, but developer style, with data, code, and a meme or two thrown in. We will be having some code demos along with the talk, and towards the end of the talk, we'll share a QR code with you so that you can look at all this code leisurely. Our solution to this problem involved a 3-step process, which is to validate contract, to enforce contract, and to simulate contract. And when we talk about contract, we mean API contracts and not those pieces of papers that lawyers obsess over. An API contract is something that stipulates the behavior, the expected behavior of an API. The first step, of course, is to validate that this contract is working well. And we recommend performing this validation in 3 different levels. So at the first level, what we are doing is we are just checking if an endpoint delivers the right status. This is how we started off. We had a bunch of endpoints that we depended upon, and we ensured that they were delivering the right status. At the second level, we go beyond status and also look at whether the API is delivering data in the right format. At the third level, we go beyond all of that and look at specific data that is required for our front-end tests. And we ensure that this data is coming through from the API side. Now, these three levels are cumulative. And if you use all of them, you have robust API tests. So now let's take a look at how this looks like in the code. So let me open up my IDE. So for our code samples, we'd be using Karate, a test framework which we love using. We can certainly recommend using Karate, especially for API testing. And what we are looking at right now is the first level of validation, where we are pinging a bunch of endpoints and ensuring that the status is what we expect. So this is what we're doing throughout. This is where we started off. At the second level, we are also going beyond this status message right here, and also going on to validate what the schema is. For instance, we ensure that the ID is a number, the title is a string, the rating is an object, and so on. At the third level, we insist on specific data that is coming in from the backend, and this data is needed by front-end tests. So in this case, we are ensuring that the API delivers a product with a title, men's cotton jacket, with a price $55.99. So like I mentioned, these three levels are cumulative, and a good API test with some best practices thrown in will include all these three levels. As you can see here, we are validating the status, but we are also validating the schema. But instead of having the schema clutter up our tests, we have them separately in a JSON file, which is adjacent. And there is another test here where we are validating if that particular product that we looked at is coming in from the backend. But instead of hard coding that product in the test itself, we have it tucked away in a test data configuration file, which is storing all this data centrally. So this way, if you're using this data across different tests, you need to change it only in one place. So now I'm going to push this run button and see what happens when I run this test. And meanwhile, I'm going to fervently pray that these tests execute successfully. For once, my prayers were answered. And this is also confirmed by the report. Let me refresh this report. And we can see that all tests were executed properly. So now getting back to our presentation, let us look at our simplified setup again and see what has changed. So in addition to the front-end tests that we already had, we now have a layer of contract tests that validate the external API at 3 different levels. And here's the thumb rule. For every front-end test that depends on API data, we have a corresponding contract test that ensures that this data is coming in the first place. Now, this is what really speeds up the analysis of your tests. So the moment you see that a front-end test is failed, you only need to see if the corresponding API test is working. And if that has also failed, you already know why your front-end test has failed. Nevertheless, the best contract validation isn't enough, because a contract is only as good as it is enforced. And that is what we'll be looking at in the next section. Now, contract enforcement originally at our partner looked like this. They documented their API using Swagger, and they mentioned that this Swagger documentation is going to be kept up to date. Nevertheless, this promise wasn't always kept up. We saw that this documentation tended to deviate from reality quite a lot. They would change something in the API, they would forget to update this page here. So this tended to decay. At our end, we stored key data that is required from the API in tables in Confluence. But these tables are also static tables, and it takes a tremendous amount of effort to keep them in sync with your tests. So our remedy to this problem is to use your code as contract. Rather than define your contract as static documentation that lives somewhere, define your contract as tests that run green. That's why they're called contract tests. So anything that is stored in the form of a Confluence table can also go into a test data configuration file, which again flows into your tests. The same applies for user-specific data. So this is far more elegant way to solve this problem, and your contract is fulfilled only if these tests are green. But as for troubleshooting, that was still a big pain point. So here is an example of how we did troubleshooting with our implementation partners. We found that something was broken. Hey, our test user is logged out, please fix. And their response invariably is always to gather more information to debug this. Which environment is this happening on? And so these conversations go back and forth, back and forth. There are usually cryptic screenshots involved. And then there's silence. One eternity later, our test user is still logged out. Any updates? They are out of office. Maybe their colleague can help. And we're back to square one. So our solution to this problem of debugging using teams is quite radical. And our solution, we recommend that you give your tests to your partner and have them test on your behalf. Now, I can sense some skepticism in the room as to why your partners are going to be thrilled for testing on your behalf, because they didn't do that earlier, right? This is what we thought. But the moment we gave our tests to our implementation partners, they were more than enthusiastic to actually accept these tests and test. And that's when we realized that the problem we face, the pain we face, is also felt by them. Every time we interrupted their work, they had to put everything aside and look at what we needed fixing. And they were also not thrilled by debugging using information bits that we threw across a chat window. By giving them your tests, you're giving them a clear expectation of how you want their API to behave. You're also giving them precious data to help them debug these tests. So please give it a try. So far, we've looked at how you can validate and enforce contracts. Nevertheless, you still have a one-to-one dependency on this backend API. The moment something is broken at their API's end, something is going to break on your front end as well. So let us look at how we can go from curing broken tests to how you can prevent them in the first place.
5, 6, 7, 8, 9, 10. Oh, I got to 10 on the microphone test there. Yeah, you can hear me now. Yeah. Thank you. Thank you. Okay. So this is where we get to the third part, which we called to simulate the contract. I should give a quick disclaimer here that this is work in progress for us, not the part of the talk, but the actual doing this. And what do we mean by simulating the contract? So you remember our setup from earlier? We have our dev system running directly against our external API, or rather the dev version of their external API. And as you saw, marked by the red lightning bolt, if something changes on the external side, something usually breaks on our dev system. Now, how do we go around this? The solution, the approach that we're taking is to put a mock server in between both of them. And the intent here is that we have this mock server that can accept requests from the dev system and answer with mocked requests, but it can also forward those requests to the actual API and respond with the answer that comes from the external API back to the dev system. The idea here is this way you can slowly build up this mock, kind of test the waters. It doesn't have to be everything all at once, immediately complete separation from the external API. Now if something changes on the external API and you have it mocked, your dev system will not break immediately. It will just show in your contract tests. You can notify your partner team about them, but still keep on developing in the meantime. Now, why should you do this? Two of those points I already made. You increase the stability of your dev system. You increase the reliability of your front-end tests actually as well, because if your dev system is broken, so are your front-end tests. But also it gives you other advantages. Since you have control over this mock, you can easily reset state changes. For example, if you have tests or user interactions that make permanent changes on the API, like ordering out all of the products or something like that, you will not have to reach out to your partner team to reset it so that your tests have like the same state when they run the next time. You can just do it yourself. And actually, this is also supposed to reduce stress in both teams. On our side, obviously, our dev system is not broken all the time, which is nice. And on the other side, there's less time pressure when something breaks, because they will know that we can still continue with our development in the meantime. Since we're building up the mock gradually, the question is what to simulate. And obviously, you should start by identifying the most unreliable endpoints, the most flaky endpoints. Usually you will know which ones they are. Mock those first for the quick wins. And then you can also use this in development in general. When both teams are working on a new feature that maybe it relies on a new endpoint on the other side, you can have your developers write a quick mock of this endpoint before it's done and already start developing the front end side. And in the end, you can check the two sides against each other and maybe make minor adjustments. And the third point is a little bit of a specific one. There's cases where, for example, you're developing for some kind of high security infrastructure, and you simply do not have access to the same endpoints from your dev systems that you have in production. And in this case, obviously, you also need a mock. Now we're running into this problem of keeping everything in sync again, because if something changes on the external API, we have to change it on our mock. And now the proposed solution for us here is we already have our contract tests. We're running them against the external API. They're checking that the external API is adhering to all of the contracts that we're expecting it to. We can now simply take the same tests and also run them against the mock. And we will have now a system that tells us when one of the systems is responding differently than the other. And so if we have a failing test on one side here, but not on the other, we will know that something changed, that something's out of sync, even if our partner team maybe didn't tell us about a change. We will just immediately know. So this is the theory. Let's look at the code again. You can actually use Karate to write a mock server as well, which we did. We have a very simple mock server here. It defines some endpoint, in this case, the /products endpoint, and accepts a get method, and then just responds with a predefined response that, once again, we have in an external JSON file, which looks something like this. More on that in a second. I can now run this mock, and running it is as simple as using a small Java command. You need a jar file, in this case from Karate, to run it, and you tell it which mocks to use, which files to use. We have two here, and which port to run on. Pretty simple. And I'm going to run it here. Hope that it works. Looking good so far. Let's have a look over here. I can check it in my browser. And oh yeah, it's over there. Okay. Yeah, the actual content here is not that important, but you see that there's a response from our mock. And now I will check that this mock is actually in line with the API that we tested against earlier. Anupam was running the tests against the test API that we're using. And I will now run the tests against it, against the mock instead, by giving it a different command here. And I will also fervently hope and pray that these tests run green. And I'm seeing a lot of red here. So actually, these tests did not run successfully. We can have another check in our reports. And we see there's some red down here. That's not good. Quick look into it. I can see here the actual response does not contain the key password. Now, I know you can argue whether or not an API should give out user passwords like that, but that's not the point here. The point here is that in my response data, I'm missing something that the actual API is now giving out. And I will just add it here quickly. This is not my actual password, I promise. And I'll have to quickly restart my mock since I changed some of its data. And then I will try to run these tests again. And this time I'm actually praying that they're green, because if they're not, I made some mistake. And we have a success. Everything's looking good. Tests are green. Checking here. Yeah, everything's in sync again. Now, all of this being said, this is a work in progress. There's other ways to do this. There's ways where people just copy the entire API on the other side and use that as a mock. But this is our approach that we're currently implementing. So let's have a quick summary. We started with a lot of broken tests. We did in stage 1 try to validate our contracts by gradually building them up again. There's a theme here. You start by just validating the status, then looking at the actual schema of the responses. And in some cases where the response is always supposed to be the same, you're looking at the actual data that comes back in your tests. You then use these tests as your contract to enforce the contract. If you have the possibility, you can give the tests to your partner. They will probably be thankful for it if you communicate it in the right way. And lastly, we simulate the contract and we try to mock away the pain and live happily ever after, I guess. Thank you very much. This is the QR code leads to this link that's underneath it. It's a GitHub repo with all the code that we've been showing. We have some credits here. We're using the fake store API to run all of this. And that's the talk. We're here for questions. Thank you very much.